everyone, I hope you're all doing very well today. Welcome to the Simactive online training session. My name is François Riendo, I'm the photogrammetric workflow specialist here at Simactive, and I'm going to be your host for this session. Today I'm going to give away 10 tips to get the most out of your drone data when processing with Correlator3D software. So let's start right away. What are you going to learn today? So by giving away the 10 tips, I'm going to cover different topics. So this is going to go from pre-processing the data before getting in the software, managing large projects efficiently, how to optimize your hardware to get faster processing, how you can improve the output quality of your deliverables, and more. So the tip number 1 is carefully plan the data collection. As you're going to see, the first 2 tips I'm giving away are related to things that are happening before getting in the software. So even before you start processing in Correlator3D, there's obviously a couple of things you need to think about. And the data collection is one of them. Obviously very important, your survey. So we recommend to use a flight planning software in order to help you to get a good flight configuration with stable parallel flight lines and a proper overlap. Also, check for good weather conditions. Try to avoid days where there would be too much clouds or wind. Ensure you have a good lighting conditions because it's going to affect directly the quality of your images. Should you do parallel flight lines or grid configurations? I would say that in Correlator3D, in most situations, we recommend to do parallel flight lines. So except if you have a very good reason to do grid configuration, you should do parallel flight lines. You're going to have less images. It's going to be faster to process. Your survey is going to be easier. So if the goal is to produce mapping products like mosaic, ortho, elevation model, there's no reason to do grid configuration. With parallel flight lines, with the proper overlap, you're going to have plenty of observations on one object to generate 3D information. So regarding the overlap, we recommend a minimum of 70% in the flight direction and 50% between the side laps. So this is a minimum. You can raise this to something like 80, 60. But on the other end, don't go with too much overlap. Obviously, this is going to make more images in your project, so longer process. And don't go below the minimum because then you're going to have problem during the bundle adjustment and the aerial triangulation. So minimum of 70-50, and a good compromise would be something around 80-60. Should you acquire nadir images or oblique in terms of viewing angle? For mapping production, we recommend to try to acquire images with top-down camera, so nadir viewing. Again, with the flight configuration and the overlap, even if your camera is pointing down, you're going to have plenty of observation. The 3D will be enough to create 3D and stereoscopy in your block. So we recommend to use nadir top-down camera. Regarding the area coverage, you have to think about maybe getting a few more flight lines on the side of your project to be sure you are covering everything. So sometimes we see people there, they have an area to cover and they're going to fly with very tight coverage. And so once you're on the field, it's not very much longer to maybe take an additional 1 or 2 flight lines on the boundaries of the project. So this way you ensure that once you are in the office and you start the processing, you won't have any gap around your project because you're too close or you don't have enough coverage to cover all of your areas. Tip number 2, clean your input data prior to processing. So again, before getting in the software, now you come back from the field, you have a drive with a lot of images that you have acquired. There's necessarily some cleanup to do in this data. So remove all the turnaround, takeoff, and landing images that you have. So don't include this in the processing. Remove them from your project. Also remove images that would have a very large viewing angle. So a good way to do this is to browse into your data set of images. You could open the Windows image viewer and you click on the arrow, and quickly you're gonna go through all of your images, and then if you see something that is with too much view angle, that you see the horizon because the drone was turning or something like that, then remove this from the processing. That won't be useful and that would just bring confusion. If you have a very large project, probably maybe you did different missions to cover your area, so put all of your different missions in specific folders. That will be helpful, because during the project creation you're going to need to define different cameras for all of these missions. So if you have one single flight, one single mission, put all of your images in one folder, in the same folder. And on the other end, if you have different missions, put them into specific different folders. Here's just a funny one. Do not include a selfie of the pilot. It's just to say that we receive a lot of project, and sometimes we see there's kind of different images in the data set, and we see there no cleanup where that was done prior to sending the data. And so you should really consider that for processing, you need to keep only what is necessary for photogrammetric processing. So what consists of your parallel flight lines with the camera top down, and remove everything that is not related to this. So don't expect the software to do the cleanup for you. Software is a photogrammetric processing software. It expects to have images that will meet the specification of a photogrammetry project. So you need to do the cleanup yourself before creating a project and importing your image. So bottom line, include only what is necessary for photogrammetric processing. Tip number 3, validate results first on a smaller data set for larger projects. So if you have a very small project, 100 images, you can start processing of your complete project without any problem. It's going to take maybe 1 hour to get your results. But when you start to having very big project, maybe more thousands of images, 2,000-3,000 images, then processing the complete project can take many hours and even maybe a couple of days if you reach 10,000 of images. So that would be a good idea first to select a representative small area of your project. That could be maybe around 50, 100 images, 4 or 5 flight lines. And with this small sub area, you can run all the processes manually. And for each processes, you're going to be careful on the parameters, and you're going to validate and do some quality checks at the end of each process to be sure that you have used the right parameters, that everything is fine with your data. And so if you just have 50 or 100 images, that's going to take less than 1 hour to have result, and then ensure that everything is good for your project before you start processing the thousands of images that you have in your project. So after the quality checks, you're going to maybe adjust the project parameters if necessary. So you're going to validate everything in the workflow, in your input data, in the parameters of the processing. And then you're going to be sure that when you're going to launch the large project, everything is going to run smoothly. So you're going to maybe even be able to think to automate your project now that you have validated on a small area. Then you can run the larger project maybe with a script or with the automated workflow. Tip number 4, always review the aerial triangulation results before moving on to the next steps. The aerial triangulation step is one very important, maybe the most critical step of the processing, because that's where the software is going to refine the camera position, calibrate the sensor, so all the accuracy of the steps that are going to happen after the aerial triangulation, all the accuracy will depend on the aerial triangulation results. So it's very important to validate this step properly. But before that, you have to define your needs and the project scope. So what are you aiming to in terms of accuracy? What are your expectations? And even this should be done at an earlier step before doing the survey, because maybe you're going to adjust the elevation of flight or your sensor depending on the accuracy you need to reach what your customer expect. So you need to define that. So you have some goal to reach, some specification. So when you're gonna review the AT report, then you're gonna ensure that you are meeting your specification, that what you just defined at the beginning of your project. So it's important to learn how to analyze the report. So once you do the aerial triangulation and you complete the bundle adjustment, there's a report that is generated. This will show you some residual error on the tie points, on the ground control point. You're going to see the camera adjustment, the camera calibration. So you can review this report and ensure that everything is fine in the aerial triangulation. In the same vein, you want maybe to do quality check at each step of the workflow. That would be a good way to go. So once you have generated your elevation model, you will need to review them. You can use the graphics environment of Correlator3D to review the result of your elevation model and try to see if there is no bad data in the DEM or anything that would need to be edited. The same way goes for the ortho. When you have generated the ortho, you can review them in the graphics environment. Just a quick check to see everything is fine. And with the mosaic, you're gonna pan into your mosaic to see that all the color balance and the seam lines, everything is good. You have a good color balance, seamless mosaic. So you're looking to find out if there is any issue in your mosaic. Tip number 5, select an appropriate resolution for the DSM generation. So the DSM is probably the most demanding process of the workflow in terms of time. That's the longest one, I would say. Probably sometimes can take 40-50% of all the processing. So it's very important to define what you need in terms of resolution. First, let's just talk a little bit about the difference between a raster DEM and a point cloud, because that's two different things. In Correlator3D, by default, we're working with raster DEM. That's a regular grid, a matrix of elevation that will be in the format of a geotiff. And that's what the software uses if you want to do addition or when you generate a terrain model out of the surface model. The software uses this format to work with. A point cloud would be a different type of format. It is a cloud of points. It's more like a vector format. So it's different. It will be an irregular cloud of points. And so these two formats can be generated with Correlator3D. But the point cloud will not be edited. That's if you want to do addition in the software. This is going to be done with the raster DEM. Then there's different concept. There's different terms to talk of the same thing when we talk about pose spacing, resolution, density. That's all different words to talk about what level of detail you want to achieve with your elevation model. And so you may be tempted to go at the resolution that will be the same that your input image. So I would say 1:1 resolution in that case. Obviously, this is going to generate a very dense elevation model, but that's going to be very long, and it's going to create a very large file size. And it's maybe not the more optimal way to go if, for example, what you want to do is generate ortho. A good rule of thumb for ortho generation, you can go to up to 5 to 10 times the resolution of your input image in terms of special resolution for your DEM. So let me just show you quickly in the software. When you launch a module, the DSM generation, the software will first estimate it, so the resolution base of your input image, and it's going to propose by default what we call an optimal resolution. So here it's the optimal resolution is 5 times the resolution of your input images. And so if you want to do very dense elevation model, you can choose the maximal, that would be 1:1. But in most cases, we don't recommend to do this very dense type of elevation model. A good compromise would be to go something in between at about 3 times the resolution. So here it could be 0.03 centimeters approximately. That would be good. But you can start with the optimal resolution, see if the results are good, and if it's if you have very good result, then you can think of maybe push to a large, a denser resolution. So as I was saying, just to conclude, choose a resolution that matches your requirements. Tip number 6, define exclusion areas for DTM extraction. So in Correlator3D, as you may know, there is a specific module that can be used to extract a DTM out of a DSM. So this is an automatic module that will try to filter out trees, buildings, cars, and keep only the bare earth terrain. So you're gonna have no more surface object, only topography and terrain. So you're gonna generate a terrain model out of your surface model. So obviously if you do a DTM extraction on all this area, probably the bridge and these structure will be smoothed and maybe even removed, because the bridge will be seen as a surface object. But sometimes you want to keep the bridge in the DTM. So there is an option when you extract the DTM where you can draw a polygon around an area, and when you launch the DTM extraction, that is going to be used as an exclusion. So again, I'm going to show you this in the software. So the DTM extraction module is very simple, but here you can use a constraint and you can load an exclusion area. And here, for example, we have excluded, let me just close this. It's gonna be easier to see. So you see that we have used a polygon to exclude the DTM extraction around the stockpile over here. So if I show you the DSM, so here I have this DSM with the buildings and some cars, but I also have some stockpile with very steep topography. So if I launch the DTM extraction on all of this surface model, there's probably some filtering and smoothing that is going to happen on the stockpile, and I don't want this. So what I'm going to do is I'm going to use an exclusion area on some, you see I even put some polygon around these here. And so when I'm going to run the process, the software will just filter and remove object in the area where there is no exclusion. You can use the online data that we load in Correlator3D to help you identify what could be area to exclude, or you can generate just a quick ortho with the DSM. That will be helpful to help you draw polygon and know where there's bridges or open mines that you would like to exclude from the DTM extraction. So exclude anything that would be bare earth or bridges or a structure that you want to keep in your DTM that you want to be filtered out. In place of using the automated DTM module, you will choose to use the DEM editing module and manually remove features. So let's say you have an open mines and there's just a couple of trees or maybe 1 or 2 buildings. That would be maybe a better idea to manually edit the DSM to remove the surface object and kind of generate manually a DTM than running the automated DTM extraction that may create too much filtering on your mine, on the wall of your open pit. Tip number 7, disable images to perform processing on smaller region. So that's one very interesting tip here that I'm giving away that I think many people sometimes are overlooking in Correlator3D. That can give you a lot of flexibility or how you want to process your project, especially for a large project. So here I'm going to talk about the difference in the software between unselecting and disabling images. So if we go in the software again and we look on the project tree on the left, you see that you can have all the images here in the input images, and you can, if you want, open them and close the images. So this way you kind of closing the images from the display. This is not the same thing that if you look on the right, you see this icon like disable images. This will help you to disable images from the processing. So for example, if you want to remove one flight line here like this, you see now the flight line is grayed out, and you launch the DSM generation, the DSM will be generated only on these two flight lines. So you can disable a camera, you can disable the flight lines, or you can disable single image one by one. And this is a way you can manage what you want to process in terms of areas, or in terms of selecting what you need to process. The same goes for the ortho. So once you have generated all the single ortho, you can disable some of them so they won't be used for the mosaic creation. So that's here. It's a good tip if sometime you're gonna have one or two orthos that are very dark, or that have some shadows that you don't like, and people are sometimes asking me how I can not use this ortho into the mosaic creation. And so the way to go is to disable this ortho from the processing by using this option here. So you can click on the screen. If you click on one images on the screen, they're gonna help you to locate what is the images in the project tree is. So sometimes when you have a lot of images, that can be difficult to find out what image you need to disable. But if you click on the center of the image on the screen, this is gonna automatically select the image in the project tree, and then you can disable this image. As I mentioned, you can disable a whole camera data set, flight lines, images, or single orthos from the processing. Another thing that is very interesting is you can change the ortho on the mosaic folder to run on different areas. So again, I'm going to go in the folder because that's a very, very important thing here to know in the software. So you have to know that when you launch the ortho generation, so if I'm going to launch the ortho and I'm processing, this is going to overwrite the existing ortho that are here, that are already being created. And the same goes for the mosaic. If I launch the mosaic creation and I'm starting the processing, then the existing mosaic will be overwrite. So how could you manage different area without overwriting the existing ortho? So you can do this by changing the ortho folder. So right here, if you click on this icon here, you can create a new folder, and you're gonna give in a new name. So for example, to create a folder, you're gonna call it ortho area 2, for example. You create this ortho folder, then you see all the orthos disappear because they have been unloaded from the other folder that was then set by default, but they are not deleted, it's just unloaded. And then if you decide to disable, let's say, fly line, and just want to generate ortho on the sub area, Then when you will launch your ortho generation, these new ortho are going to go in a folder you just created, ortho2. And then you can go like this and create another folder, ortho3, and then generate another area. So that's the way then you can generate all these different sub area, either for the ortho or for the mosaic. The same thing, mosaic, you can define another folder if you want to generate a new mosaic. I often as well use this. Sometimes I want to generate a true ortho. So you can see a lot of option in the software to manage how you want to manage your project, depending if you need to generate sub areas, just a small sector, or different type of processing with different parameters. So you can disable images, change the output folder, and do all of your different processing with these options. Tips number 8, optimize the hardware to accelerate the processing. So obviously this is a question we have a lot of times, is what is the best hardware, how many times it's going to take to process with this type of hardware. These questions are sometimes very difficult to answer because there's a lot of parameters that are in play to know how many times it's going to take for a certain type of project. That goes from the resolution of your images, the number of images, the specific hardware you have. So it's practically impossible to give a very accurate answer about that. But what I'm going to do today, I want to show you two different settings of hardware and how much it's affecting the processing time. So here I have a first project. It's the same project, same number of images, same resolution, but we are going to compare for different hardware specification how much time we're going to improve with a better computer. So this should give you a good idea of how much the hardware is affecting the processing. So you know that Correlator3D is a GPU powered software. We are optimized to use the graphics card GPU memory. So a lot of the processing are using the GPU and not much the CPU, not much the RAM. So basically the most critical component that you need to have if you want to have good processing is a good graphics card. You absolutely need an OpenGL compatible type of card like an NVIDIA, GeForce, that type of card. And I would say the next most critical component will be your hard drive. So having an SSD drive is what will also improve the processing. Then if you have more RAM, good CPU, that obviously will help, but not as much as the GPU and the type of hard drive that you have. So here on the left, I have a very basic NVIDIA 540 graphics card. And on the right, I have something like a better one, like a 1050, with a little more memory. And here there's a mistake in this report. It's actually an SSD drive here, so just don't consider this here. It's really a SSD drive that was used for this test over here. So better graphics card, SSD drive here, kind of low-end graphics card with a standard HDD drive. And you can see that in this case it took 3 hours and 38 minutes to process the 290 images. And here in that case it's 44 minutes, so it's a big improvement. It's about 5 times faster just by having a better graphics card and an SSD drive. And so you see that you can really improve the processing speed with a better computer. But bottom line is you don't necessarily need, on the other end, to have a big, powerful, very expensive machine. What we try to say to people is that you can buy a standard computer with a good graphics card and SSD drive, and you should expect to have a very good processing speed on this machine. So let's review all of this here. So as I did the performances comparison, and I've shown you that by improving your hardware, you can get better processing speed. But obviously, update and clean your system. Always have plenty of space and try to have updated drivers. It's very critical for the graphics card. Sometimes we see that people, they don't update their graphics card driver and they're 3, 4, 5 years old. Always update your driver for Correlator3D because all the new version of the software will take opportunity of the new development in graphics cards. So it's very important to have an updated driver. And again, no need to invest in very expensive hardware. Some of these graphics cards, you can get something very decent starting from $200 and maybe a little more if you want to have something a little very more powerful. Here's a good question. Do I need to process on the cloud? So I take here the opportunity to just take a little bit about processing on the cloud. Correlator3D is a desktop software. It can be installed on the cloud, so you can configure a virtual machine that would be on AWS, on Azure. You will have to configure this with the proper instance, and then you can install a desktop version on the software on this machine, and you can process on the cloud. Obviously, some of the advantages with using cloud is you can configure a very powerful machine. You can access this machine from different locations. But on the other hand, you have to keep in mind that you're going to need to transfer all the time imagery onto AWS. So that's going to take a lot of bandwidth on your internet connection. And at the end, you won't necessarily have faster processing than what you can have on a desktop. So it's really a matter of what your organization needs. If you have a very big organization and you need to access the processing from different offices, different location, the option of using the cloud can be interesting. But if you're always doing small projects, survey project, I think you can even have a laptop, bring this on the field, download your images, processing them in ad hoc while you're on the field, and that's going to be a lot faster and more efficient than setting up a cloud, uploading the images, processing your project, downloading the result. So it's really something you need to analyze, and don't get trapped in the hype of necessarily the need of going on the cloud. I don't think it's really necessary for, in many cases, you can still run Correlator3D on a local machine, and that may be more efficient that way. Tip number 9, use scripting for batch processing. So as you know, everything that you have in the Correlator3D graphics environment can be scripted and can be automated using scripts and command line. And so that's a good way to optimize your processing. And we have many customers that like to do this, and that was one of the advantages of our software, is that everything can be scripted in a very efficient way. So probably in one other training session, I'm going to go more in depth into the scripting, but here's something to bear in mind, that this is something you can use to optimize your processing. Now we have a new automated workflow. Maybe I would like to take just a few seconds to show you the automated workflow. So you can access the automated workflow from here. And now what is new is that all the steps of the workflow can be pre-configured before you just launch the processor. And there is even some profile that you can select from. So by default, that's the standard UAV project. It's going to do a true ortho. It's going to process at an optimal resolution. So you see, if you want to generate a point cloud, you have to check this option. So you can kind of select different parameters before you launch the automated workflow. And what is interesting is you can use that to generate a script. So that's a good way to start scripting. So you can specify all of your parameters, and then you generate the script, and then you can edit and personalize or customize that script. So that's a good way just to quickly generate a script, and then after that edit it and optimize it for what you need. So how to create and run script? If you go in the Correlator3D user manual, at the end you're gonna have everything that is explained, how you can use the script and how you can run them in a command line. So I recommend that before, if you want to start to use script before starting, take a good read of the user manual where we're talking about that. And also, as I mentioned, look for probably in the next training session, I'm going to talk a little bit more about processing using the script. So I've covered all the advantages of using scripts. One of them is that when you're doing script, if something is wrong at the end of the project, then it's because something is wrong in your script, and you can easily find maybe what is the parameters. You still have a trace of what you did, as opposed to when you are doing everything manually. Sometimes you may forget what are the parameters you have selected, but with a script it will be always there, so you can consult what are the parameters that you enter in your script, and if something you want to change. So it's very efficient, to double check what was your how you set up your workflow, and if there's something to change, when you can just change it in the script and run it again. Tip number 10, edit results for deliverables of superior quality. So even if we just have talked about scripts in Correlator3D, there's a lot of options also where you can manually edit your output, and to reach something even better that was the software has generated automatically. So the software is not just a black box where you press a button and you have result. We also have implemented some tool that will give you control on the outputs and give you, so you are able to edit your outputs and before you want to deliver to your customer. So that's how you want to interact with the automated workflow. Again, I mentioned the automated workflow will generate everything at once, and so you will have all the output generated. Then after that, maybe you can use some of the editing tools to edit your deliverables and do some fine-tuning. One thing that cannot be automated right now is the GCP editing. So if you want to have ground control points, you will not be able to run all the automated workflow. You will need first to manually do the aerial triangulation to measure your tie points. So you're going to import your tie points on the software, and then you're going to be able to go into the images and locate your points with the GCP editing tool. Then after that, once the aerial triangulation is done, you can run the remaining processing with the automated workflow. There is a DEM editing module in the software that can be used to edit your DEM. So if you see that you have some bad elevation, things that you want to edit out from your elevation model, you can use the DEM editing module, and in this module there is a lot of different tools that can allow you to filter out objects, smooth area, remove object from the DSM. For example, you want to remove trees, flatten out a surface, so if you want to flatten out a body of water. So all these tools, you can use them to reach a better elevation model before you're gonna do the mosaic or the ortho. Because bear in mind that the ortho rectification is a lot dependent on the quality of the elevation model. So if you have bad elevation in your dam, this may affect the quality of your ortho. Even it can create some artifacts. So sometime artifact in the output mosaic will be created by the dam. So you can use the dam editing to fix these problems and remove anything that you don't like. And finally, there's mosaic editing tools that you can use to edit the seam line, the cut lines that are generated when you assemble the mosaic. So all the cut lines can be edited. If you don't like where the software has created these seam lines, you can use the mosaic editing tools to change the location of the seam line, edit this. So you have to control how your mosaic is assembled. So for example, if there's one cut line going straight into a building and it makes a kind of apparent joint between two ortho, then you can edit the location of this seam line to go around the building and to go into area where it will not be apparent in terms of the seam lines. So that way, this is a way you can deliver high quality results. So you see that in Correlator3D, there is a lot of tool to help you deliver superior high quality results. So you're gonna have other software, maybe they're just very highly automated, just a black box. You don't have the control on the result. As I show you in Correlator3D, there's a lot of flexibility in terms of what you can edit or how you can manage your workflow in terms of processing sub area when I shown you how to disable images, for example. So all of that makes the software very flexible and probably help you to get higher quality result than with other solution. So let's review together all the 10 tips that I gave away today to get the most out of your drone data. So the tips number 1 was to carefully plan the data collection. Number 2, clean the input data prior to start processing in Correlator3D. Remove everything that is not useful for the photogrammetric processing. Tip number 3, you have to validate the result first on a smaller result for large projects. If you have very big project before starting the processing on, let's say, 3,000 images, just do a small project of 50 images and do all the processing on this project and validate all of your workflow in the result before you start processing the old data set. You're going to save a lot of time if there is some problem to identify. Tip number 4, always review the aerial triangulation results before moving on to the next steps. Tip number 5, select an appropriate resolution for DSM generation. So select the appropriate resolution, so it's gonna maybe take it's gonna be faster to process if you select a lower resolution, if you don't necessarily need to generate a high density elevation model. Tip number 6, define exclusion areas for DTM extraction. Tips number 7, disable images to perform processing on smaller regions. Tip number 8, optimize the hardware to accelerate processing. As I'm showing you, the most critical component are the graphics card and the drive. Having an SSD drive will be very helpful for processing speed. Tip number 9, use scripting for batch processing. Tip number 10, edit the results for deliverables of superior quality. And I'm giving you just a bonus tip. If you have any question, you can ask our experts. We are always available to answer any question you will have during a project. Our support is there and we try to answer the same day as you will ask your question. We know that time is important for you, and when you're stuck in a project, we will very consider your question and answer as fast as possible. So thank you very much for attending. I hope this was very useful for you. If you have any question, do not hesitate to send them out to us. And I hope I'm going to see you for our next training session. My name is François Riendo, and I'm wishing you a very good day. Thank you. Bye-bye.